Designing combinational logic circuit. Okay, so we will continue on K-map. Okay, for designing combinational logic circuit, so we have 3 steps in designing combinational logic circuit. Okay, first you need to construct truth table. Okay, second you need to write the simplified expression, and then the third one you need to draw the logic circuit. So actually we have done for this step in chapter 3, but for this chapter we will use Karnaugh Map, okay, to simplify the expression, which is for the second step. So we look at example here. Okay, so this is an example. So diagram above, okay, is a system to control 3 valves: P water, okay, PX, and Py. Okay, so this valve we control the flow of water. Okay, so we have water. Okay, we have a liquid X. Okay, and also liquid Y. Okay, so this 3 valve we control all the flow. Okay. So we look at the description of the question. Okay. So during the initial state, the tank is empty. Okay, when the system starts, okay, the valve P water is open to allow the flow of water. Okay, as the water level reach at level A, so the next valve PX is open to allow the flow of liquid X into the tank. Okay, when a mixture of water and liquid X reach at level B, so valve Py is open to allow the flow of liquid Y. So when it reaches level C, our valves are closed and green light is switched on, signaling a successful operations. So this tank, okay, uses 3 float switches, A, B, and C. If any of the switches fail to function, all valves are closed and red light is switched on. Alright, so based on the question, you need to understand the operation of the system. Okay, because our first step is deriving the truth table. So your truth table must have 2 parts, input and output. Okay, so based on the question, okay, based on this diagram, okay, and also the explanation of the system, so you need to figure out how many variables, okay, for this question. It means that for the input, and then you also need to think how many output, okay, for this system. Okay. So looking at this diagram, so the input is actually the float switch, okay, because this float switch will control, okay, the level, okay, the water level, okay, liquid Y, also liquid X level inside this thing, okay, inside this tank, okay, inside the tank. Okay, so that's why your input is A, B, and C. Okay, and then for the output, okay, based on the diagram, I know you can see that we have 2 light, okay, green light and red light. So green light and red light, there are the 2 output, okay, for this system. But the output not only for these 2 light, okay, we also have another 3 output, which are the valve, okay, valve Py, Px, and also P water. Okay, because the valve will control the flow, okay, of these 3 liquid, okay, including the water. Yeah. So based on this description, okay, you can fill in the value in your truth table. Okay, so now we continue for the first step. Okay, we start with our first step, okay, which is the truth table. Okay, so A is truth table. Okay, so your truth table, your input, okay, you have A, B, and C. Okay, so because you have 3 input, so that's why you need to have 8 combination of binary. Okay, combination of your binary. Okay, so you have 8. Okay, so I list down all the combination. Okay, this is for B. Okay, and then the last one is for C. Okay, for output, okay, output you have 5 output. First one is P water. Okay, and then you also have PX. Okay, you have PY, and then you have green light, and then you have red light. Okay, so this is the list of your input, okay, and also the output, okay, for your first step, okay, which is deriving the truth table. Okay, so I draw the line for each combination. Yeah, so you can fill in the value after this. Okay, so we have 5. Right, so the operation of the system is actually based on this description. Okay, so you look at the first statement here. So during the initial state, the tank is empty. Okay, when the system starts, the P water is open to allow the flow of water. Meaning that you need to find which combination here, which combination of your input represent the elaboration, okay, or the explanation or the statement here. Okay, so you need to find what means by A0, B0, C0, okay, because the system is actually have 3 float, okay, that we control the flow of the water X and also Y. Okay, so each value is actually represent the position of the float. Okay, so here, okay, we have the logic level to represent the input and also the output. So you have input level, okay, logic level, float off 0, float on 1, and then for the output, valve open 1, valve off close 0, light on 1, and light off is 0. So based on the input, when A is equal to 0 means that the float is off. So what means by the float is off? Float off is actually the water or the liquid X and also Y is actually below that float. Okay, when float on, it's actually when the water level or the PX or the X and so Y is actually above of the float. Okay, so for the description here, for the first statement here, okay, when the system start, valve P water is open to allow the flow of the water. So which combination that shows you the system is start? Okay, because the first sentence said that during the initial state, the tank is empty. So tank is empty is actually this combination, this one. Okay, this is start. Okay, this is start. So what happened when the system is start? Valve P water is open. So means that P water is open. So what happened to the other output? So it will be 0. Okay, so just P water is open. And then next, as the water level reach level A, the next valve PX is open to allow the flow of the liquid X into the tank. So you need to find the combination here that shows you the water level reach level A. So water level reach level A means that you need to find A is equal to 1. When the float A is equal to 1, float on. So you have 4. Okay, 4 A equal to 1 here. So which one that will represent this statement? Okay, so based on these 4, Okay, only this combinations shows you this is a level A. Okay, level A. So what happened? Okay, when the water reach level A, so the next Px is open. Okay, what happened to the Py? Okay, Py also, sorry, Pw. Okay, Pw or P water. So P water also still open. Okay, why? Because you go to the next statement when the mixture of water and liquid X. So meaning that at the level A, P water still open. Okay, P water still open. Okay, and then the other outputs is equal to 0. Okay. Next, okay, when the mixture of water and liquid X reach level B, WAF P at Py is opened. Okay, so which combination that shows you okay, the water and also liquid X reach level C? Sorry, level B. So you need to find the combinations shows you at the level B. Okay, so this combination shows you level B. Why? Because at this combination, A is 1, B also 1. Okay, meaning that the water level okay, is float on of A, and at the same time you also at the float B. Okay, is float on. So that's why okay, this representing the level B. Okay, level B. Okay, so what happened? Level B, WAF Py is open. Okay, so including all three, the other two WAF. Okay, P water, Px, and also Py. So green light and red light is 0. Okay, and then last, okay, when it reach level C, all WAF are closed and green light is switched on. Okay, signaling a successful operations. So this combination shows you the last one, okay, which is level C. So what happened? Green light is on, the other WAF and also red light is switched off. Okay, so the last statement, if any of the switches fail to function, all WAF are closed and a red light is switched on. Okay, based on this elaboration and also the truth table that we have done, so actually we have several combinations that don't have any value for the output. Okay, for example, for the second row, so what mean for the second row? Which level of the liquid in the tank? When C is equal to 1, B0, A0, meaning that float A off, float B off, float C on. Okay, so this is something that not logic, right? So the other combination is actually representing the fail to function. Okay, maybe the floats are fails to function. So that's why when the float fails to function, so you need to put the output based on the last statement. So all WAF are closed and the red light is switched on. Okay, so this is red light is switched on and the other value is 0 because closed. Okay, so this is our first step, okay, based on the elaboration or the explanation. Okay, so this slide also explained okay, the operation of the system. Okay, you also can refer to this slide. Okay, and then this is the truth table, actually same as the truth table that I show you here, okay, at the whiteboard. Okay, so next step is actually the second step, okay, which is the simplification, okay, the truth table, okay, using K-map. So you have 5 output. Okay, based on this truth table, you have 5 output. That's why for your K-map, also you need to have 5 K-map. Okay, 1 K-map for each output. Okay, for example, if you refer to the P water, okay, if you refer to the P water, okay, so this is a P water. Okay, so P water, the value in the K-map is actually based on the value in your truth table here. So you just map, okay, the value. For example, the first value is 1, okay, at cell A bar, B bar, C bar. So this one, A bar, B bar, C bar, the first value. Okay, and then you have another value is A, B bar, C bar. A, B bar, C bar, and the last one is A, B, C bar, A, B, C bar. So you have 3. Okay, you map, and after that you loop the cell. Okay, and then you write the simplified equation. So same goes with the other 4 output for PX, PY, green light, and also red light. So if the value is only has one value, for example for PY, so PY only has one value, you still need to map to your K-map. Okay, because the question asks you to simplify using K-map, so you need to use K-maps, okay, to all outputs. Okay, so PY is actually equal to A, B, C bar. Okay, A, B, C bar, only one value. So if your value is only has one value in your K-map, so you can loop the value, okay, or you doesn't have to loop, but you still need to write the equation. So same goes with the green light. So LH is actually referring to green light. Okay, lampu hijau ni. Okay, this is lampu hijau, LH. So green light also has only one value, which is A, B, and C. So you map, and then you write the equations. Okay, and then if you refer to red light, so red light or LM, okay, LM is actually representing red light. So red light, you have 4 value, 1, 2, 3, 4. So here you also have 4. Okay, and then you loop. So based on this K-map, you don't have to overlap. Okay, you don't have to overlap the cell. Okay, you have 2 cells. Okay, right. So this is the second step. Okay. And then the last step, based on the equation. Okay, so you draw the logic circuit. Okay, you draw the logic circuit. Okay. So all output must be combined in one logic circuit. Means that you need to use the same input A, B, and C. Just you you show the different output. Okay, but using the same input. Okay, so for P water, okay, if you refer to your equation P water, so you have A, C bar plus B bar and C bar, and then your PX also have A, C bar. Okay, so if you refer to this logic circuit, okay, this is the P water. Okay, so for PX, okay, you just take the same gate or the same circuit, and then you just put the output. Okay, so this is another way how you can draw your logic circuits, meaning that you doesn't have to draw the same circuit twice or the same gate twice. Okay, if the gate is already in your logic circuit, so you just draw another line, and then just put the output at the end of the line. Okay, I hope you can get what I mean here, right? So this is the last step, okay, logic circuit, and then you need to label based on your K-map. Okay. Alright, so the last one, okay, before I forgot the most important things is actually, okay, so when you write your equation for your K-map, okay, you need to put the variable here, okay, variable for your output, okay, which is the output. Okay, the output for each K-map must same with the output of your truth table. Okay, so if your truth table use PW, so here also you must use PW. Okay, PX, so you also need to use PX. Okay, because some of students, instead of the variable here same with the truth table, so they tend to use Y. Y equals to AC bar plus B bar and C bar. Here also Y. So all the variable they are using Y. Okay, so you cannot use the same variable to represent different output. So you need to refer to your truth table. You need to follow this variable. So whatever variable that you are using in your truth table, so you need to use the same variable for your key map. Okay? Same goes with your logic circuit. So this is the designing. Okay, how we can design combinational logic circuit. Okay, for second step, which is simplification. Okay, by using K map.